done, I told you at one point you'd have a homework quiz on Wednesday in 7-3. That's not gonna happen. So Thursday would be the earliest you could have a homework quiz in 7-3. Alright, so so 7.3, most of the section is all about volume. Finding the volume of something. So the first type of problems you'll have are like using their cross section. Okay, so that doesn't make sense to you right now, but we'll hopefully clarify a little bit with a problem. Of course, we have our x, y, z axes. Can you see it? And let's say I have.
So is x and y like would be flat and z would be up?
Coming up, yeah.
Oh.
Okay.
So let's graph y equals sine x. So can you see it?
Yes.
So we're only going to use from 0 to pi, so we're going to be done there. So that's going to be the base of whatever we do. And the cross sections, let's make them squares to begin with. Right, so I have Can you visualize that?
No. What am I supposed to be?
The square coming out of the base. So there's a whole bunch of squares.
Oh, okay, I got it.
Is it better when I erase it?
Yes.
Okay, so each cross section is going to be a square whose base is between the x-axis and sine x. So all of these squares are different sized.
So they're squares? But they look like diamonds.
Because
An angle.
It's 3D.
Because it's 3D.
He's just really artistic, so just
Like the flat base.
3D.
so think of the semicircle flat on the ground
Yeah.
and the squares coming up.
What kind of shape is that?
It doesn't really have a shape.
It's
I
like
mean,
okay.
the
It's
volume
like
created.
it's like a
Square, square,
trapezoid.
square,
Don't know.
smaller square.
Okay, I'm going to do 4 or 5 of these. So this is just the first one. Hopefully it'll make sense when we do a few more. Okay, so all we have to do is integrate a of x from 0 to pi. Okay, where a of x is the cross section of one of the shapes in that interval. So we're integrating a of x dx from 0 to pi. So how do I write a of x in terms of x? Well, we know it's a square, so it's just base times itself, so base squared. So how can I represent this distance?
X.
Why?
It is y,
Oh, wow.
which is in terms of x, in this case, it is sine x. This distance right there is sine x. Right? No matter where we are, if I had like, this is pi over 4, how far is that? It's the sine of pi over 4. So this distance is just the y value, which is sine x. So my a of x is actually just what? Sine x squared dx from 0 to pi. And that will give you that volume. So the real math is figuring out what a of x is.
Will like there be these pictures in the book? Well, I guess
In a couple, and sometimes you have to draw them.
Sometimes you have to draw them.
Yeah.
Do you have to draw them, or like if you like know which is which?
No, you don't have
just-
to.
Okay.
It won't be a requirement.
Okay.
Okay, so same scenario. I'm not going to redraw it, but let's do a different cross section. Let's say it's half circle whose diameter goes from x, the x-axis to sine x. So can you see that this is a half circle? So that's kind of like, you're gonna get bigger and then smaller again, kind of like the back of a armadillo, if you can imagine that. It gets bigger, and it gets smaller. No?
I get it.
I see it.
Yeah.
Okay, so that's when it's
See, from now on, you're like, I could probably approximate the volume of that armadillo back.
None of them are flat, they're all 3D.
Pretty much.
You just can't
So wait, are you using that half circle as the cross?
That's my new cross section.
Or is it-
So, your question would be, find the volume whose cross sections are semicircles, whose diameter lie in the xy plane that go from the x-axis to y equals sine x.
So you need to do half of diameter times.
Right.
pi.
So see if you can figure out what a of x would be in this case.
Oh.
Wait, so those are standing straight up?
Yeah, the half circles would be standing up on the Z.
Is that diamond or rectangle, whatever, relevant?
So it's kind of
That's the
shaped like a
previous
banana.
problem. Now we're just doing the next.
Okay, this is a new problem. Okay.
Yeah.
Oh, I see.
That was throwing me off, 'cause I thought they were both.
Alright, so we know that a of x for green is 1/2 pi r squared. This is a half circle. So it's pi over 2, whatever our r is. What's my radius here?
Sine x over.
Sine x over 2. We only want half of it. That's sine x. Half of it is sine x over 2 squared. So there's my a of x. And once you have that, I guess you could make that over 4. So it's basically pi over 8 sine squared x dx from 0 to pi.
Aren't you squaring the 2 at the bottom of the sign?
That's how we get 8.
So that's 4
Oh,
times 2.
yeah.
So is that what they're asking you for? In the
That
fall?
will
Then
give you
just
the volume.
integrate it.
Well, that'll give you, that's the integral in which to find the volume.
So then,
And
do we
solve
need to analytically integrate that? Or?
Yeah, if you were going to, you'd have to do a power reduction.
Yeah.
But you can, if you want to save time in this assignment, I don't know if you read that in the notes, but you can do your integrals on your calculator.
Yeah.
Okay, on the tests and quizzes, you will be asked to do them by hand, but there's nothing new as far as integrals go, and if you wanna practice, you can, but if you wanna save time, you can just plug it in your calculator. So maybe go through one time through the assignment with your calculators, and then if, in preparation for the test or quiz, you can maybe go back and try a couple by hand.
I figured out my calculator was in degrees, that's why it wasn't working.
Oh, nice.
Yeah.
Okay, so that's one type of a volume, cross section. Let's say I have to, I'll do one more example. I'm never gonna make it through all the work, all the notes today.
You tried
We'll
really hard.
Probably go through maybe
So what does
3
this section
titles.
really do?
We watched
Yeah,
the
it's,
first.
the homework quiz would potentially be Thursday at the earliest.
We watched the first couple on Friday, like we
That's
watched.
awesome.
the
Shh,
video.
we said we wouldn't
So
tell
where
them to
did-
be smart.
I already heard, yeah.
Sorry.
Oh, yeah, sorry.
So where
But
did you
then
go to my
wouldn't have to
YouTube
do as
page then?
much.
Yeah, they were.
We went
It was
until you were
confusing.
done with like what you did, like it was weird because you were doing it on a Friday and you were like, oh, but we'll do this stuff on Monday, which
Oh,
is like actually
perfect.
kind of what we were doing.
Did I have brown hair back then?
I don't know.
It's not what we're
You
trying to
didn't-
pay.
Yeah, then you changed outfits because we went in the first reason watched and we were like, oh yeah, it's Monday.
You're definitely explaining better in person than on the
Okay.
video.
We went to.
Alright, so let's do,
Yeah, you've improved that teaching.
well, that's great. Now I gotta think of an example.
Haha,
Do the diamonds.
put you on the spot. Those are
Triangle.
Area of it.
X equals Y squared.
Let's just do it.
Let's just do
X
this plus or
between
minus
0
square.
and 4. mean volume,
It's a sideways parabola.
right. Whose cross sections
You should really switch back to graph paper now.
are,
Ah, you switched
we'll say squares to begin with, but then I'm gonna make it more difficult. Okay, so the squares in whose base are in x, y plane. Alright, so I'm going to draw this one for you too.
Alright, I'm not
X,
gonna-
Y, Z.
X, Y,
This
Z.
is the only type of problem that I graph in 3 dimensions, if it makes it feel better. So x equals y squared is a parabola that looks like this, right? Did we know that?
Yep.
'Cause you could solve for y equals, so it'd be square root of x and negative square root of x. So there's my sideways parabola, and I said that I would go up to 4. Okay, so there's my region.
Can our calculators graph in 3 dimensions?
I think the 89.
84 scan? That's boring.
We probably can't do 89.
That'd be so cool.
These cross sections are squares based in the xy plane that connect with these. There. So here's
There.
one of my cross sections.
It's really hard to draw this all in the same color.
Need more flavors.
Oh, I just realized I need to draw.
And
So
it's
see if you
squares.
can find that volume.
June.
Alright, so we are integrating a of x dx from 0 to 4. And I know I'm integrating with respect to x because my change in shape is in the x direction. So you'll have some that are integrated with y. It's not much different, it's just a shape in the y direction. Alright, so my a of x is a square, so it's just base squared. So if I can figure out what my base is in terms of x, well, this is x equals y squared, so it might be helpful to say that's y equals the square root of x, and y equals negative square root of x, right?
Sure.
So how long is this on the bottom?
2x.
2 square root of
2 square roots of x. Good. So you could go like that minus that, square root of x minus the negative square root of x, or just know that that's a square root of x, and that's a square root of x. Distance-wise, so the bottom is 2 square roots of x. Squared.
So then that makes the other
So it's
side.
an integral of 4x dx from 0 to 4. Anybody get that?
Nope.
Most definitely.
But I understand.
You understand.
Understand
I
good.
think I could solve that interval.
Alright, so
Four.
let's say that my new cross section is an equilateral triangle whose base is in the same spot. So this is now an equilateral triangle.
I'm ready.
They get a trapezoid.
Okay, wait a second. Now the area would just be,
Can you see it?
yeah.
Okay, so sub-problem. How do you find the area of an equilateral triangle if you know one of the sides? So if I call this A,
Oh.
what is its area? See if you can figure that out. I'll give you a couple minutes.